Hello students, welcome to Vedantu J English. I am Diksha Kaushal, your chemistry master teacher. And this session is for those students who are preparing for, who have their shifts on 7th and 8th of April. So without wasting any time, because I know how precious time is for you at this moment. So without wasting any time, we'll start with some very important questions that we have analyzed from the previous shifts. Okay, in the end, I'll also tell you some topics that you must do before giving your exam. So let us start that without wasting any time. But before that, I want everyone to fill the chat box with green hearts and positivity, and let us dive into the session. So coming up with the first question here, as on your screen, firstly let me know in the comment section if the screen is completely visible to you. Now students, the first question is molecular shape. So one kind of questions that are there definitely going to ask, 100% guaranteed question, is based on hybridization of coordination compound and the hybridization of chemical bonding. Okay, so molecular shape of SF4, CF4 and HCF4 they are asking, right? This is very repeated and this is also a repeated compound, right? So talking about the molecular shapes here, how you're going to answer this? So first is for SF4. Now I'll tell you how to answer this. SF4. Sulfur, first you will have to find the central metal atom. Okay, central metal atom is sulfur. So you will say sulfur is belonging to group number 16. That means outermost electrons are 6. So 6 minus 4 are already involved in the bonding. So 2 electrons it is left with. So 2 electrons means 1 lone pair. So 1 lone pair plus 4 bond pair, that combines to 5. That is sp3d hybridization, which is, it is trigonal bipyramidal. That means 1, 2, 3, 4, 5. But 1 is lone pair. And this question has been asked in your latest shifts, that lone pair in the previous shift only. In yesterday's evening shift, they have asked one question based on the lone pair, where we should attach the lone pair in the trigonal bipyramidal. So lone pair will be on the equatorial position. This one, and this one. These are the equatorial position. This one and this one is the axial position. Okay, on the axial position, electron negative metal will be applied. Okay, so here you will have one lone pair, right? And these are F, 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 and that corresponds to seesaw shape. Okay, that corresponds to seesaw shape. Is that clear to everybody or not? Next, let us see. They are asking you CF4. Now, CF4, if you want to solve this, you can solve this as well, or directly also you can answer this, that it will have the same shape as CH4. How? Because carbon, if you see, similarly, let us do this for carbon, CH4, right? Carbon is having, it is belonging to group number 14, right? So it is 4 outermost electron, all are involved in bonding, so it is 0 lone pair, and that is why it is going to have sp3 hybridization with the tetrahedral shape. Next one is, last one is XCF4, okay, XEF4. So xenon, which belongs to group number 18, that means 8 outermost electron minus 4 are involved in bond pair. You are left with 4 electrons, that means 2 lone pairs. 2 lone pair plus 4 bond pair. Together it corresponds to 6. 6 means sp3d2. 6 means sp3d2 for xenon 4. But the shape is different because it has octahedral geometry, and you have to attach 2 lone pairs here. On these position you will attach the lone pairs, and this is your FFF. So this is going to be square planar shape. Square planar shape. Now they can ask you any molecule there, you have to answer it in the same manner. So here answer is going to be, as you can see, answer is going to be, they are asking you the molecular shapes of this, they are asking the lone pairs. So they are different with, it has 1 lone pair, it has 0 lone pair, it has 2 lone pairs. So 0, 2, 1. So it will, 1, 0, 2. They have 1, 0 and 2 lone pairs here. So they are asking question of different things. Shapes, lone pairs, mixed questions with coordination chemistry. These kind of questions is what they are asking. Next is The structure of noble gas compound HCO4, we have just seen, that is xenon, 1, 2, 3, 4, 1 lone pair, and the shape is going to be, this is forming the square, so that is going to be square planar shape. So answer is going to be A is the correct answer. Next question, how they can ask you more questions here. Let us see. A molecule of XY2 contains 2 sigma, okay, 2 sigma, 2 pi and 1 lone pair. A lone pair of electron in the valence shell. The arrangement of lone pair as well. Okay. So see, first you have to find the hybridization here. Hybridization is number of sigma plus lone pair. Sigma is 2, lone pair is 1, so it corresponds to 3, that is sp2, right? So that means sp2 corresponds to trigonal planar. So answer will be, this will be, let's say A, B, B, 1 lone pair here and 2 pi bonds will be present here. It has a shape of SO2. For example is SO2, right? Example is SO2, right? Next question is trigonal planar. Next is, which of the following molecule does not have linear arrangement of atoms? Linear arrangement of atoms. Okay, let us see that. First is C2H2. This belongs to CnH2n. Okay, is it CnH2n? Is it C2H2? Okay, CnH2n minus 2. That means it belongs to alkyne, right? So here it is C triple bond. C, this is H, this is H. Definitely it is a linear combination. B2H2, B2BeH2. Beryllium. Beryllium belongs to hydrogen, helium, lithium, beryllium. That means 4, right? That means 4. Out of 4, 2 are already involved in the electron pair, right? And so the formations that they will have is first is H2S also, right? So H2S is definitely not going to be, or this is also linear, this is also linear. This H2S is not following a linear combination here, right? Okay, H2S is not forming a linear combination. So answer is H2S is the correct answer. Now, I'll just give you one very important thing here, students, so that you are able to answer these questions in the exam as well. So for example, they have given you sigma plus pi. How you're going to solve this? Sigma plus lone pair, right? If it is 2, 3, 4, 5, 6, or if it is 7, right? It is sp2, it is sp3, it is sp3d, no, it is sp, it is sp2, it is sp3, it is sp3d, it is sp3d2, and this is seventh wali is basically pentagonal bipyramidal. Okay, so let us see this here. This one corresponds to linear, right? This one corresponds to trigonal planar, right? Planar. This is tetrahedral. This chart you have to remember in the exam. Trigonal bipyramidal, right? Then you have next is octahedral. This one corresponds to octahedral. And the last one with 7 is pentagonal bipyramidal. Pentagonal bipyramidal, or yes. Okay. So that is the shapes here. This is basically the geometries. And always remember, in geometries we calculate bond pair and lone pair both. But when they ask you shape, ignore the lone pair. That is how you will tell the shape. Very, very important chart. Definitely this will help you in chemical bonding. Just go through this chart. That is directly one question will be there in the exam based on this. That is guarantee, maybe 2 questions also sometimes, right? Next is 200 milliliter of, now let us see from the mole concept what kind of questions are asked. 200 milliliter of 1 molar HCl solution is mixed with 800 milliliter of 2 molar HCl solution. Calculate the molarity of the final solution. So molarity of final solution is M1V1 plus M2V2 divided by V1 plus V2. This is what you have to put here. Now, if you're putting the volume, right? If you're putting the volume here in liters, okay, if you're putting the volume in liters, then how you're going to solve it? This is going to be 200. Either you put all of these in milliliters or you put all of this in liters, totally your choice. Let's put all of this in liters, so that will be 200 plus this will be 800 into 2, right, divided by 200 plus 800, and by solving this you will get your answer. Okay, by solving this you will get your answer. Now they have basically here what they have converted this into liter. This all will be cancelled out. So I have not just divided it, I have converted everything in liter, milliliter only, because eventually volume milliliter will also cancel out, liter will also cancel out. It's just that the unit should be same. If you are picking here liters, here also it should be liters. If here you have milliliters, here also it should be milliliters. The units of volume should be same on both the sides. Okay, is that clear? Next is manganese oxide is heated in a stream of hydrogen to give water and new oxide this. If 17.4 gram of MnO2 produces this much of MnXOY, then what is the ratio? Now these kind of questions have very high probability. Reason being because here the mole concept, very simple question based on mole concept, and reaction based is what they are asking in every single shift. Okay, so here first you have manganese oxide, which is going to give you, manganese oxide is heated, which is going to give you this MnXOY. Okay, so that is the reaction. Okay, that is heated and it is going to give you MnXOY. Right, now what they have given is that you have is heated in stream of hydrogen to give water and this oxide. This much of manganese oxide you have, this is already given, produces this much of MnXOY. That means this is given to you, this is given to you. Now if you calculate the number of moles here, so that will be MnO2 is basically what, 55 plus 16 into 2, and you will get 87 as the full molar mass here, right? The molar mass of this will be manganese has 55 multiplied by X, oxygen is 16 multiplied by Y. That is the molar of mass of MnXOY. Once you have the number of moles here, so whenever you apply POAC on manganese atom, that means you have to equate the number of moles on both the sides. Okay, so that is 17.4 by 87 is nothing but it is 1 by 5 only. Okay, we just solved this. So you just need to equate both of them. When you equate them, you will get the value of Y by X as 1 by 2. So what I did, I just applied POAC, that I equated both of these, because here also it is 1 mole, here also it is 1 mole. So even if, let's say, what is basically POAC? It says that number of gram equivalents are always going to be equal here. So that's how, even if it is 2, 3, whatever, this whole will be equals to this one. That is how I applied here, and you will get the answer of Y by X as 1 by 2. So answer will be Mn2O, right? Mn2 is going to be your correct answer. Is that correct? Okay. Next is, in fact, that is the ratio, right? I'm just talking about the ratio here. The s orbital does not show preference to the direction. Now, the same question has been asked, not same, but the language was different. Okay. So, what we have seen that repeatedly they are asking you the same kind of questions. So, by changing the language, this s orbital does not show preference to any direction because it is smallest orbital, it is present in every atom, it is spherically symmetrical, it is the first orbital. Reason is it is spherically symmetrical orbital. Okay, as you can see, it is a very spherically symmetrical orbital. Now the question that they have asked is that it is directional, it is symmetrical, right? So from that, this question also they can ask you, which is slightly changed version of the previous question. Now, what we have seen is a lot of questions they are asking you from aldol condensation. Okay, from aldol condensation, a lot of questions they are asking, right? Most of the shifts they are asking aldol condensation. So, if you talk about aldol condensation here, they will not directly give you that this is aldol condensation, right? So, I have picked out two questions. One, in the previous shift, they have asked one question on intramolecular aldol condensation. That also we will do. And this is basically, this is also your intramolecular only. Okay. So, now we have to see how these two are going to react with NaOH, and this is ethanol, and this is water. So, aldol condensation will take place here. What will happen? So, this is your entire molecule. In aldol condensation, firstly, the base is going to abstract the alpha proton. So, this is the alpha proton. Ma'am, I want to abstract this alpha proton, abstract. Whichever alpha proton you like, you can abstract that. Okay. So, both are symmetrical only. So, it is going to abstract this alpha proton here. When it abstracts this alpha proton, this will become negative, and this electron is going to attack on this. Electrons are going to jump here, and this H positive will be shifted to this side. Okay, so this CH, this will be converted to OH here. These two, alpha and carbonyl, are going to link together, and here you will have the CHO over here, and that is going to be your final answer. Ma'am, is there any simpler way to understand this? Okay, no worries, no worries. For those students who don't want to get into any mechanism, this thing is for those, okay, who are like, ma'am, I hate mechanisms. Okay, so what I told you, in one thing, keep the CHO as it is. Okay, here keep CHO as it is, and make alpha hydrogen open. Here, open the carbonyl carbon. Now, what you have to do here? You just have to, this is alpha, this is carbonyl. You just have to join these two together, convert this into OH, right? Convert this into OH, join these two together. Let's say I have joined this. Rest of this hydrogen is shifted there only, and that is your final answer. Okay, what I did, alpha and this. If you're, ma'am, I'm very confused in this, ma'am, what they did. So directly what you have to do is alpha and carbonyl carbon. Wait a minute. Okay, just give me a minute. Okay. Just give me a second, students. Just give me a second. Just give me a second. Okay. Okay, now let us see the next questions here. Here the answer is going to be C is the correct answer. Achha, after this you also have to see from the alpha and beta position you have to take out water, OH from this side and H from this side, and it will generate one double bond over here. So that is the thing you will have here. That is why this will be your correct answer. This is going to be the correct answer in the end. Double bond, and this is COH. Is that clear to everybody? So this is a question based on intramolecular aldol condensation, which they have asked so many times, right? Okay. Next is now A and B in the chemical reaction, you have to identify A and B here, right? So firstly you have HCl, then you have NaI, okay. HCl means double bond, it will break. NaI diacetone means it is Finkelstein reaction, okay. From the naming reaction and from the reagent, they are asking you sequence A, B, C, D, E, these kind of questions, okay. So here it is, you have OCH3, no. This is H positive, Cl negative, Markovnikov addition will be there. So here, ma'am, both are same only, either this or that side, because it is electron donating. So here electron density will be more. So here you can say that this is resonance, है ना? Here you will not have that. So basically you can have the Cl over here, okay? Then attack the Cl over here, right? Because this is attached to OCH3, right? Then after that, we know that this is Finkelstein reaction. Finkelstein reaction is one of the naming reaction, halogen exchange reaction. Cl will be replaced by Ni and that will be your final product. That is B is going to be the correct answer first and this is your second one. Got it? Next is the major product formed in the following reactions. So are you able to see this? Again, what we will do here? Dilute, whenever you see dilute NaOH, concentrated NaOH, just see whether there is some aldol or Cannizzaro reaction happening. So if you see this here, this is alpha and here you have this as alpha. That means easily aldol condensation can take place here, right? But the point is which alpha it is going to use in this case, okay? Point is this alpha or this alpha it is going to use here. So what you will see that base will attack on that proton which is more acidic in nature. So one is this CH3, C double bond OH proton, this proton, and one is this proton. Now because of the resonance that is involved in this case, because of the resonance that is involved here, this proton is going to be more acidic, right? So this alpha proton is going to be more acidic here. That is why it is going to take out one proton from this side, right? It is going to attack here. One proton will be eliminated and you will have this negative and this is CH2. Now this is going to attack on this carbonyl carbon. This negative is going to attack on this carbonyl carbon. Electrons will jump here. You will have CH3, CH, because electrons double bond is jumping here. So it will be one H here, H. Then here CH2 is attached to this side, CH2, then CO, then this is benzene. And hence it is going to be your correct answer in the end. So answer is going to be C is the correct answer. Okay, C is your correct answer. Understood? Yes, everybody? Next is choose the correct relation. Now, very important question based on ionization enthalpy and the size, exceptional values they are asking you. So, if you ask me, ma'am, what is the correct relation of ionization enthalpy here, right? So, first is only seeming to be correct. Why? Because if you talk about lithium, beryllium, boron, carbon, nitrogen, oxygen, we know that it follows an opposite trend here. Lithium, then you have boron, beryllium, then carbon, then oxygen, then nitrogen. Okay, this is the order. Okay, if you see, wait a minute, ionization enthalpy is, yes, increasing. That is going to be the order here, right? So if you see this here, lithium and beryllium, ionization enthalpy of lithium, wait a minute, the correct relation they are asking now. So this is ionization enthalpy of beryllium and lithium, if you say, is greater than lithium and sodium. Okay, this is down. Okay, this is lithium and beryllium. So now if you see this here, lithium and beryllium, beta, can you see the difference here? Here the difference is of 1 step. Here the difference is of 2 steps. So they are asking you the difference here. Lithium sodium is definitely less as compared to lithium beryllium. Here you have 2 steps, here you have 1 step. So that is why lithium and beryllium is greater as compared to lithium and sodium. The difference of lithium with beryllium and lithium with sodium. So lithium with beryllium is greater because of this exceptional trend. So see how smartly they are asking you the same question but in a very different manner. Right? In a very different manner they are asking you the same question. So answer is going to be A is the correct answer. Answer is going to be A is the correct answer. It was a very important question. Next is, which of the following is incorrect for electron affinity? This they have asked you in 2 to 3 shifts till now. So regarding electron affinity, that which order is incorrect, like these kind of questions. So this question also they can ask you, which of the following is incorrect for electron affinity? So if you see this here, electron affinity of alkali metal is positive. Yes. Affinity means the tendency to gain electron, that I want to gain the electron. That is affinity, right? So here, electron affinity of inert gas is positive. No, inert gases are like, I am not hungry at all. I don't want to gain any electron. So that is why electron affinity of inert gases is going to be negative. That is the incorrect statement. So answer is B is the correct answer here. Next question we have is, in the following sequence, see you have, this is sequence based, so we will just directly see what exactly we are doing here. So this is nothing but acetylation. That means one hydrogen is replaced by COCH3, right? After that, in acetylation, wait a minute, where it was? In acetylation, whenever you are adding Br2, that will be attacked to the para position first. Okay, so para position is this one here. Achha, para position is not available to us. Para position is not available. It is already occupied. Then it will think, oh my god, para position is occupied. Where should I go? Okay, I can go to the ortho position then. Then it will choose one ortho position and it will attack on the ortho position. Hence, answer is going to be A is the correct answer. Very good, very good. Okay. Next is, this compound is given to you. Again, they have asked you, firstly, we are doing acetylation. Then we are adding Br2. Then we are adding base and we are heating it. Okay, so let us see what exactly we are doing here. So first is acetylation. So directly what will happen here? In place of this hydrogen, you will have the attachment of COCH3. Okay, COCH3. Then you add Br2. Br2 means Br positive electrophile will be generated here, right? So Br positive electrophile will firstly try to attack on para position. Para position corresponding to this is empty, so it will attack on the para position. Br positive electrophile on the para position. After that, you are heating it, right, with the presence of the base, or you are basically adding water here. So directly what will happen? This NHCOCH3 will be converted to NH2, and this is going to be your final answer. That is C is the correct answer. Okay. Yes, students, if you are able to understand these questions, then let me know in the comment section. And I also want you guys to answer, okay? What is this? Anybody in the comment section, what is this? So many times till now in every shift this question they are asking, right? So based on amines and aldehyde ketones, they are very like in love with aldehyde ketones. From aldehyde ketones, they are asking aldol, canizaro. Amines, they are asking mixed questions, right? With a mixture of aldehyde ketones and alcohol also. So here it is, diazotization, right? So firstly, what will happen? Diazotization. After that, what is this? CuCN, KCN. Salt you are using. Sand-Meyer reaction. Basically, you are going to add CN over there, right, on the benzene ring. So here it is, you have NH2. First you do diazotization. This will be converted to N2Cl. Then add CuCN, KCN. That means CN is going to replace this N2Cl, and that is the answer that you will get. So answer is going to be very good. Answer is going to be A is the correct answer. I can see you guys answering in the comment section. That means your preparation is going really, really good. Okay. Now let us see. Here you have what this is, diazotization. After that, Cu2Br2, again Sand-Meyer's reaction. Then this is HNO3, H2SO4. That means nitration also we are doing in the end, right? So first thing is, you need to learn the things about reagent and naming reaction. If you actually, I can guarantee you will score full marks in organic chemistry if you have knowledge of reagents and naming reactions. So here it is, diazotization. This will be converted to N2Cl. After that, add Cu2Br2, that is Sand-Meyer's reaction. This is converted to Br. Now you have to, here also it was Br, na? So you have two Br. Now you are adding concentrated HNO3. The question is, ma'am, where the concentrated HNO3, this NO2 positive electrophile should attack on which position? Okay. Corresponding to this, you have this is ortho, this is ortho, this is para. Right? This is ortho, this is ortho, this is para. This ortho is not possible because it is sterically hindered. Then the position we are left with is this ortho and this ortho. But we have just one NO2. We have just one NO2. NO2. Then what will happen here? It will try to have that which is para. Okay. So para will be preferred over here. So answer will be this is preferred. Even now, even if it prefers this one, corresponding to this, it is going to be para, right? So answer will be same, right? So answer, even if it prefers this one, then also this is the answer. Even if it prefers this one, then also this is the answer. But if you have one choice, then you will choose para as the major product here, right? So answer is going to be C is the correct answer. Okay. Next we have is glucose and galactose are. Glucose and galactose are definitely epimers of each other, but at which position? They are, the chirality is changing on the 4th position, as you can see here. Here OH is on the right side, OH is on the left side. Other things are same in glucose and galactose. So they are epimers of C4 epimers. What is this? They are epimers of C4 epimers. Very important question. Next is we have Dumas method. Mark it, beta, very, very important for sure, right? Either Dumas method, chances, most are of chances of Dumas method only, but they are asking you question on percentage in every single shift. Okay, every single shift. So in one they ask percentage of carbon. Dumas method, so it has been asked in three questions, three shifts till now, right? So here it is in Dumas method. I'll just tell you what is the method of doing this. That is the method of solving this. In Dumas method for estimation of nitrogen, 0.3 of an organic compound is given. They are asking you the percentage of nitrogen. So whenever they ask you the percentage of nitrogen, just remember mass of nitrogen divided by mass of organic compound, that is given to be mass of organic compound multiplied by 100. Now we know that mass of nitrogen we don't know. We will solve that. Mass of organic compound is given to be 0.3. 0.3. Now if you see this here, give 50 milliliter of nitrogen collected at this temperature, at this pressure. Calculate aqueous tension is given to us. First here you will see the pressure of nitrogen here. Pressure of nitrogen is atmospheric pressure minus aqueous tension, that is 700, divided by, if you want to calculate this in atmosphere, because this is given in mm of Hg. So first thing is to calculate the pressure of nitrogen in atmospheric. That is why I divided it with 760. That is the first thing you should do. Second is, we know that number of moles of nitrogen is equals to PV divided by RT. So pressure is given to you, that is 700 divided by 760. But the same step we are following in every single shift for these kind of questions. They are only changing the values here, right? So you will be very lucky if they ask you the same question that they have asked in 3 shifts till now, right? So here it is 50 milliliters. So we will convert it into liters here, right? Then after that you have to divide this. R value will be 0.821. Temperature is given to be what? 300. Okay. So temperature is given to be 300. I would advise you just calculate R. I don't know whether R will be 300 or what. If R is given, mostly temperature is given to be 300. So just calculate this thing here. You will get the number of moles. Mass of N2 is going to be this value here, number of moles multiplied by 28. Then this mass value you will put here, and that is how you are going to get your answer. The calculation is a task here, okay? Calculation is a major task. Otherwise, it is a very, very direct question from your NCERT. Okay? Understood? Do the calculation, you will get 17.46. Yes, calculation is a task here. Okay? Next is question on organic compound. Now from match the following also, they are asking you these kind of questions on naming reactions and on the isobaric, isochoric, these kind of processes. So if you see this, first one is Sandmeyer's reaction, right? Second one is Getterman reaction. Third one is Wood's reaction, and fourth one is this fatigue reaction. So answer is going to be D is the correct answer. A2, B4, C1, D3 is the correct answer. Next we have, now this is a very, very interesting question. Okay. So here what we have is, Firstly, you have PCC, which is a mild oxidizing agent. Okay, so what it is going to do, it is going to oxidize the OH here. So what it will do, it will oxidize this OH into ketone and this OH into CHO. So that is why here you will have CHO because it is in the terminal. This will be converted to ketone. Mild oxidizing agent converts 1 degree to aldehyde, 2 degree to ketone, right? Once we have done that, after that you have ethylene glycol. Ethylene glycol, whenever you add ethylene glycol here, so basically what you have is C double bond O and this is H. So what will happen here when you add ethylene glycol, this is OH, this is OH, water will be taken out here and hence this carbon will be attached to this oxygen and this oxygen here. This carbon will be attached to this oxygen and this oxygen. This is a formation of acetal, you can say. Okay, so this is CH, this is attached to this oxygen, and this is the answer for B. After that, you are adding MEMG, right, and you are doing the hydrolysis. So when you are adding MEMG here, so what will happen here, everybody? What will happen here? Firstly, MEMGBr. Firstly, because you are doing hydrolysis here. Remember one step. Usually we skip that step. Because you are doing hydrolysis here, so what will happen? This oxygen will attach here, one hydrogen will attach here, one hydrogen will attach here, and again this bond will be converted to CHO. That is the first thing that will happen. Okay, that means this full thing will be converted to CHO, right? Next is what will happen to this carbonyl? This is negative, this is positive. It will attack here, electrons will jump here. This will be OH, this will be methyl has attached here, so this will be CH3. After that, you are adding NaBH4 and ETOH. So that means you are doing the reduction here. Now remember, reduction of alcohol, all this NaBH4 does not do. It will reduce this CHO to CH2OH, that's it. NaBH4 does not act on carboxylic acid or either ether as well. Okay, that is also a very important question for your exam, right? Okay, so that is how you will get the answer as this is your final answer. Okay, that is going to be your final answer, quite similar to your original product, right? So it is just a twisted question where they have asked you 3-4 things here, right? Okay, now next question is given to you. You have ketone. They are saying you have to arrange the sequence of the reagents here, right? So this is a kind of question that I really expect in the upcoming shifts because they will slightly make, at least this is what happened in last year as well. Last 2 shifts is what they ask, slightly good questions in chemistry. So this is not a very difficult question. It's just the arrangement of the reagents is tough. So you have CH3MgBr Grignard reagent, you have KMnO4, you have a mild oxidizing agent, you have acid here which is going to do basically elimination here, right? So what we are going to do here, this is the compound that you have. Firstly, you have to make it this compound. From this I got to know if this is getting converted to this thing, that means CH3MgBr is definitely going to attack here. Why I am not giving CrO3 firstly, then oxidizing action will also occur on this C double bond O. Okay, so that is why firstly you have Grignard reagent here. This is negative positive, it will attack here, electrons will jump here. You will have OH and CH3 here. After that, elimination reaction, because what I need to do in the final answer is I need to have a double bond here. So for that double bond, I need to make a space for any bond here. How I will make that? By firstly creating a double bond here. For that I have this reagent, that is I have an acid which is going to cause elimination. So what will happen? OH negative and H positive will be eliminated, electrons will jump here and that will be the answer. After that we are again adding cold diluted KMnO4 which is going to, basically this is your Bayer's reagent. Okay, I'll just light it here. This is nothing but Bayer's reagent. Bayer's reagent break the double bond and attach OH on both the sides. So this is what we did here. Now, when you use mild oxidizing agent, definitely this is going to convert this into double bond O, right? Reason being, this is a 3-degree carbon, 3-degree alcohol. This is 2-degree alcohol. And mild oxidizing agent only attacks on the 2-degree, not on the 3-degree. So this will remain as it is, but this is going to change to double bond O. That is how you are going to rearrange all the reagents here. Okay, very, very, very important question. That is C is the correct answer. Next we have is consider the following. So you have to consider the following here, right? So consider the following reaction: phenol, zinc dust. Then you have here CH3 positive electrophile will be generated. Alkaline KMnO4. This is going to convert any alkyl chain to COOH, right? So reagents are given, sequence-based reaction is given to you. Phenol and zinc dust is converted to benzene. Then you have CH3 positive electrophile will attack here. Then alkaline KMnO4 means any alkyl group is converted to COOH in that case. Any alkyl group. So answer is going to be benzoic acid is the correct answer here. Next question is, you have a direct current deposits. Now, in your entire syllabus, when you have a question, right, from electrolysis, right now they are asking on rather than Nernst equation, they are asking questions on different things. Till now, they have not asked question on Nernst equation, right? Okay. So usually what we say that students only do Nernst equation, that will be beneficial. But in attempt 1 also, they were diverting towards product of electrolysis, Faraday's first and second law. These are the kind of questions that they are asking. A direct current deposited 54 gram of silver, atomic mass is given to you during electrolysis. How much aluminium? So whenever you have two elements here, that means we are talking about Faraday's second law. Atomic mass of both is given. So silver is Ag, aluminium is Al3 positive. Ag has N factor 1, so it will be 108 is the equivalent weight. Al3 positive will have 27 by 3, that is the equivalent weight, that is going to be 9. Okay, so just apply this formula here, apply this law here, that is the ratio of weight of two metals is equals to the ratio of equivalent weight of two metals. So we know that the weight of silver is given to us, you have to calculate the weight of aluminium, right? And that too from aluminium chloride solution by the same amount of electricity, right? Aluminium chloride means AlCl3, right? So here Al is in +3 oxidation state only, right? So that is why equivalent weight of Ag is 108, for aluminium it is 9, for weight it is given to be 54, and this is what you have to find. You can easily find that based on Faraday's second law, right? Next is, okay, so now these kind of questions are basically they are asking from basically the number of Faradays for 1 mole, 2 mole. It will be a mixture of mole concept and this electrochemistry. So a solution of this is electrolyzed between platinum electrode using 0.1 Faraday. How many mole of nickel will be deposited? Right? Usually they ask you the current, but to have a good question here, we have molded the question that they have given you the current, they have given you the Faraday here. You have to see how many moles you need. So see, if you see this, how many moles for 1 mole, how many Faradays you are using. So if you see this question, right, we can see that 2 electrons nickel is losing here, right? So that means 2 Faraday is used by 1 mole. 1 mole of NiNO3 is using 2 Faraday. That means 0.7, or you can say 1 Faraday will be used by 1 by 2 mole. Then 0.1 Faraday will be used by 1 by 2 into 0.1. 1 by 2 into 0.1, that is going to be the answer. So answer is 0.0, right? Okay. This is what they are not going to ask in JEE. How many bangles ma'am is wearing and why? That is not the question of your JEE, okay? So now focus here, that I will tell you after your JEE exams, right? The correct order of atomic radii in group 13 elements. Group 13 elements, guys, atomic radii. So there is one variation here between gallium and aluminium. So answer is going to be D is the correct answer. Okay. Rest is, we know that atomic radii will increase down the group, but the variation is in gallium and aluminium. They will switch the position, and this is the final answer that you have. The correct statement among 1 and now next is the correct statement among 1 and 3 regarding group 13. Now from inorganic chemistry, one is exception, question based on exceptions. Other is question based on the informations. Okay, informations is what they are asking you, like these statement based questions. Boron trioxide is acidic in nature. That is correct. Okay, boron trioxide BO3 is acidic in nature. Yes. Oxides of aluminium and gallium are amphoteric. Definitely right. Oxides of indium and thallium are basic. That is also right. That means all the statements are correct here. Right. And beta, here also note down one thing. Note down one thing here. Neutral oxides are CO, NO and NO2 and water. These are your neutral oxides. They can ask you the neutral oxides as well. Okay, they can ask you the neutral oxides as well. Those who have not done these exceptions, if you have very less time, ma'am, I don't have enough time, ma'am, I have just Sunday. Beta, I have made 1.5 hour long video for inorganic exceptions. Everything is there. You can go and check that out. Right? Now, next is the incorrect order. Now, they are saying the incorrect order values of negative sign for the 4 successive elements. Now, E naught value, remember E naught and atomization. From that table, they are asking you the questions of 3D series. 3D series, there is a table of physical. I'll send that table on the Telegram channel, right? I'll send you 2 tables for inorganic chemistry. From that, definitely you will see one question, definitely, right? So here, what exactly happens is, Saktiv Karman Fico. So answer will be this. Manganese has more, then you have chromium, then you have iron, then you have cobalt. So answer is going to be B is the correct answer. Okay, these are the values from your NCERT. Directly you have to learn the order from there. Next is the context with the transition metals. Which of the following statement is incorrect? Incorrect. In the highest oxidation state, the transition shows acidic character, form cationic. Okay, in the highest oxidation state, first 5 transition elements, this to this, all the 4s and 3d electrons are used for bonding. Okay. Only the 3d5 configuration is exceeded, the tendency to involve 3d electrons in bonding decreases. Okay. In addition to the normal oxidation state, zero oxidation state is also shown by these element in complexes. Okay. So they are asking you the incorrect statement. To my view, I think A is the incorrect because they are acidic in nature, right? Yes, in the highest oxidation state, the transition element shows acidic character. In the highest, more is the oxidation state, more is the acidic character. That is the general relationship between oxidation state and the acidic character. They are directly proportional to each other. So more the oxidation state, more is the acidic character. So this statement is incorrect here. So answer is A is the correct answer. Consider the hydrated ions of these 4, the correct order of spin only magnetic moment. Now beta, whenever they ask you spin only magnetic moment, just remember this is Saktiv Karman Fico Niku Jan. Okay. Now, in all these cases, it is 21 to 30 is the atomic number. What you have to do, 4s 3d, write 4s 3d, 4s 3d, write everywhere 4s 3d, again 4s 3d, 4s 3d, 4s 3d, 4s 3d, 4s 3d, right? 4s 3d. Now, if you see this here, what you have to do, you just have to add 1, 2, 1, 3, no, not 1, 2. It's 21, 22, 23, 24, 25, 26, 27, 28, 29, and this is 32, and this is 10. Out of this, copper and chromium are the exceptional. It will be 4s1 3d5 and copper is 4s1 3d10. If you know these electronic configuration, easily you will be able to answer these questions here. Okay, easily you can answer these questions here. Got it? So here it is going to be scandium, titanium 3 positive, vanadium. What they are asking you is the magnetic moment here. So it has 0 unpaired electron. This has 1. If you see this, titanium 2 positive has 2 unpaired electron. It has 1 unpaired electron. It has 3 unpaired electron. So unpaired electron also, if it is 1, 2, 3, 4, 5. 1 it is 1.7, 2.8, 3.8, 4.9, 5.9. That will be your magnetic moment here, and according to that you can easily answer that. That is a very important question. Next is a very important question based on the electronic configuration of lanthanoids. The lanthanoids ion that would show color. Okay, color means that will have not completely, see, color means it should not have F0 or F14 electronic configuration. All these have either F0 or F14. Samarium 3 positive does not have that. So it is definitely samarium 3 positive is what? It is 4F5. That means it is going to show FF transition. That is why it is going to be have some color here, right? Next is, which of the following complex ion has electrons that are symmetrically filled in both T2G and EG? Now question based on T2G and EG they are asking very frequently. Now if you see this, one thing is you should know which is going to cause pairing and not. Here you will have no pairing, here you will have pairing, here you will have no pairing, here you will have pairing. So let us try to answer this. Whenever you find the electronic configuration, everything, this will have X is equals to, this will be iron will be in, this is 3 now, so it will be in, wait a minute, iron will be in Fp3 X minus, no, it should be 6. I think it will be 6. I think there is some misprinting here. Okay, otherwise so it will go like 0 oxidation state. Okay, so I think there is some typing mistake here in F number of F ligands here. So I'll tell you firstly what you have to do. You have to calculate the oxidation state, that is +2. Now manganese have what? Manganese is 3s2, 4s2, 3d5. Right, that I told you electronic configuration. 2 electrons always taken out from S, it will be 3d5. Now you can see because of pairing it will be 1, 2, 3, 4, 5. It is also not symmetrically filled. Only here you can see that it is symmetrically filled. I think here it should be 6. Right, only then X will be equals to +3. Only then iron, which is having 4s2, 3d6, will have 3d5 electronic configuration. And because of F is a weak field ligand, that is why it will be symmetrical in the filling. So you just have to see the symmetry here. You can see symmetrical filling is only in this case. In cobalt also, here you will have X is equals to +3. Right? So cobalt, in cobalt is 4s2, 3d7. +3 means it is going to be 3d6. Right? So 6 electrons are not symmetrically filled. Right? Here it is X is equals to 6, it is equals to +2. So cobalt +2 is nothing but it is 3d7. Okay, so it is going to be 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. So again, it is not symmetrically filled. Only this one is symmetrically filled. So answer is going to be A is the correct answer. Okay. Next you have is the correct sequence of CO bond order in the given compounds. See, for this you have to see that very simple thing here. The CO bond order is inversely proportional to the extent of back bonding here. Now, in manganese, the back bonding is maximum, right? Okay. In iron, if you see, order of firstly the back bonding, let me tell you. Here you have the maximum back bonding and here you have the minimum back bonding. Reason being, here metal is donating electrons to the ligand. Here metal is taking the electrons from the ligand, right? So that is why minimum back bonding is present here. So maximum, then less, so it is minimum. So order of CO bond order will be opposite here. That is opposite to the back bonding here. So that is why answer is going to be this. So this is very important, very important. High chances that they might ask you this in the next shift only, right? Next is homoleptic octahedral complexes of a metal ion. This with 3 monodentate ligands. Monodentate ligands you have 3. Okay. Homoleptic means only one kind of ligand is there. absorb wavelength in the region of, see, this is, now they are asking you question depending on wavelength and delta. So E is inversely proportional to lambda, that we know. Now they have given you the value of lambda by giving you the colors. E, they are asking you which will have more energy, more energy means more ligand strength. Okay, so opposite we have here. So firstly you need to know that which lambda is more. So talking about the lambda here, lambda of red is maximum. If you say red has maximum lambda, then you have green, then you have blue, right? That is there in Vibgyor. So on this side, lambda increases. That means firstly red, then green, then you have blue, right? So lambda is in this order. That is why energy will have the opposite order. Same is the energy order, same will be the order for the ligand strength. So that is why L2, then L1, then you have L3 here. Okay, that is going to be the correct order of ligand strength. Okay. Next is, which of the following complex ions is not expected to exhibit optical isomerism? See, optical isomerism, directly if you see, this is what they are asking you. Ma3B3. This kind of complex does not show any optical isomerism, but they show facial and meridional geometrical isomerism. Very, very, very important. Facial and meridional geometrical isomerism they exhibit. They don't exhibit any optical isomerism. Okay, this they have asked you already, right? But in a different way, right? The complex, this will have how many geometrical isomers? So if you have tetrahedral complex in which all the ligands are opposite, so what you do here is you fix one position, then you interchange these two ligands, 1 and 2, these two are interchanged here, then these two are interchanged here, as you can see. Firstly, I have interchanged these two things here. Then again, what we have done here, it is NH3BrCl. So firstly, these two are interchanged. Acha. What I will do is, I will not make this one. Rather, I will make PT. This is Py. This is Br. This is NH3. This is Cl. Okay. So I would like to make this one. Reason being, because I have told you that how to interchange. Okay. This bookish thing we are not going to do. Right. So firstly interchange these two, then interchange these two. Okay. These are the three isomers you will get. Now fix any of these two. You will take any of these two as same. I will take chlorine and bromine as same. Chlorine and bromine are same, cis position. Chlorine and bromine are opposite sides, so trans position. Chlorine and bromine are same side, so again cis position. So always it is going to show you 2 cis and 1 trans. That is always going to be MACBD. So answer is always 3, 2 cis, 1 trans. That is going to be a standard thing. The ratio of radius, very, very, very important. Radius, so I think NT's favorite topic. Right, the ratio of radius of second orbit of hydrogen and third orbit, right? So we know that radius is directly proportional to n square by z here. So n and z both are changed here. So that will be how you will answer that. Radius of hydrogen will be, this is R0, you can simply say. N is given to be second orbit, hydrogen means z is 1. That means 2 square by 1. For lithium it is going to be, Z is going to be hydrogen, helium, lithium, that is 3. Third orbit means it is going to be 3 square. You just take the ratio here. These two will cancel out. This will cancel out. You will have 4 by 3 as the answer. So answer will be 4 by 3. Just remember the formulas of radius, velocity, everything. Okay. Next is, wait a minute. Let me see how many slides we are left with. Very few. Okay. So we are about to end the session, students. We are about to end the session. After that, directly after this, Namrata ma'am is going to take the session. Okay. When I'll complete this session, directly after this, Namrata ma'am is going to start. Okay, students? Yes. How many electrons would be required to deposit this much of copper at cathode during the electrolysis of aqueous solution of copper sulfate? Now, they are asking you how many electrons would be required to deposit this much of copper at cathode during the electrolysis of copper sulfate. Right? Very simply, we will answer this. Firstly, we know that 2 electrons, 2 Faraday is required for 1 mole. So directly you can say that 1 mole of copper that will require 2 moles of electron means 2 Faraday. Right? 1 mole of copper will require 2 Faraday. And they are asking you how many electrons. See, 1 mole of copper will require 2 mole of electron. 2 mole of electron. That means how many in 1 mole, what is the mass? What is the molar mass? That means 63.5 gram will require 1 mole of 2 mole of electron. So 1 gram will require 2 by 63.5 mole of electron. Just unitary method. Why unitary method I am saying again and again, you should know how to apply it, because on unitary method they are asking you a lot of questions. Okay, so 1 gram will give you this. They have given you in the question, that is 66.35. So 6.35 gram will be 2 by 63.5 multiplied by 6.35 mole of electron. When you solve this, you will get your answer as 1 by 5 mole. Now, are they asking you moles? How many electrons they are asking you, not moles. So we know that if you multiply this by Avogadro's number, right, we know that moles is equals to particles divided by Avogadro's number. So particles, here I am saying particles are electrons, so that will be number of moles multiplied by Avogadro's number. That is Na by 5 is going to be the number of electrons that are required here, right? Next is graph of between molar conductivity. Important questions regarding the graph here. Molar conductivity of 2 things are given to you, KCl and NaCl. They are saying which graph is correct here. See students, firstly you need to know which molar conductivity is more. Here you have K positive and one is Na positive. Have they asked the same kind of question? Yes ma'am, they have asked question on molar conductivity. Beta, I told you this is Na, this is Lina Ki. So this is potassium has more size as compared to Na. So more is the size, more is the molar conductivity. This we have done in the previous shift. So based on that, there is a new question which will open up your brain regarding the molar conductivity. That means molar conductivity of K is more. That means molar conductivity of KCl is more than NaCl. That is why the slope of KCl will be above than NaCl. So answer is going to be C is the correct answer. Okay, very, very important question. Very, very important question. How they will ask you these kind of question on the basis of graph. Next is which of the chemical system is non-aromatic. So remember, when there is non-aromatic means it has either no conjugation, no complete conjugation, or not cyclic, or it is not planar. So I can directly see here you don't have any complete conjugation. So this is going to be non-aromatic. This is going to be aromatic with 6 pi electrons, aromatic with 6 pi electrons, right? This is also aromatic 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 with 10 pi electrons, right? So answer will be E is going to be non-aromatic in nature. Next we have is which compound out of the following are not aromatic? Non-aromatic and not aromatic has a difference. That means they are asking you they can be anti-aromatic or non-aromatic, right? So if you see this, this is non-aromatic, this is non-aromatic, this is 1, 2, 3, 4, 5, 6, 7, 8, this is anti-aromatic, this is 1, 2, 3, 4, again this is anti-aromatic, this is 1, 2, that is aromatic. So answer is 2, 3, 4. 2, 3, 4 are under the category of not aromatic. Not aromatic, beta, we are saying. Not aromatic is 2, 3, 4. Non-aromatic is only this one. Not aromatic means either anti-aromatic or non-aromatic. Next is among this which is not aromatic. Again, you have to see anti-aromatic and non-aromatic, right? Now, if you see this here, 2 electrons, 1, 2, 3, 4, 5, 6, that means it is aromatic. 1, 2, 3, 4, 5, 6, but ma'am, double, single, double, single, double, single, double, single, double. Okay, ma'am, there is complete conjugation. It is double, single, double, single, double, single, double, single, double, single. Okay, complete conjugation. 1, 2, 3, 4, 5, 6, 7, 8. Anti-aromatic. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Aromatic. 1, 2, 3, 4, 5, 6. Only these lone pairs are involved in the conjugation. So it is aromatic. So you have only one anti-aromatic here, that is 2, which is going to be under the category of not aromatic. So answer will be 2 is the correct answer. Okay. Next is very, very important, based on hyperconjugation also. Directly they are asking you the questions. The hyperconjugation stability of tert butyl and 2-butene. So beta, when we were doing hyperconjugation, I told you directly that in case of carbocation, you are shifting from sigma to p empty orbital, because carbocation has empty p orbital. But in case of wait a minute, where is double bond? In this case, you are shifting from sigma to pi anti-bonding, right? Because it already has electrons in the bonding, so it will take the electrons in the anti-bonding. So it will be pi anti-bonding. In carbocation, it is sigma to p empty, and in double bond, it is sigma to pi anti-bonding. Very, very important question. Okay. Next is, what will be the correct IUPAC naming here? So IUPAC naming also, they are asking you the questions here. So firstly, you have to do the numbering according to the highest functional group, that is SO3H. Then after that, directly just introduce the substituents, that is 2,4-difluorobenzene sulfonic acid. That is going to be the correct answer here. Right? Okay. Just we are left with very few questions. 1, 2, 3, 4, 5 questions, right? The molar heat capacity at constant pressure P is given to you. When 1 kilojoule of heat is supplied to 1000 gram of water, which is free to expand the increase in temperature of the water. So molar heat capacity is given to you, and they are asking you the increase in temperature. For that, you should know one thing, that Q is equals to specific heat capacity mass divided by multiplied by delta T. So delta T is equals to Q divided by mass into specific heat capacity. Now ma'am, molar heat capacity is given to you. Molar heat capacity is given to be 75, right? So if you say to raise 1 degree temperature, you require 75 joules, right, for 1 mole of water. But here what they are saying is, you have, when this kilojoule of heat is supplied to 100 gram of water, this is the amount of water that you have, right? So for 1 mole of water, that means for 18 gram of water, you need 75 joules. For 1 gram, you will need 75 divided by 18. Unitary method again. For 1 gram, you will need 75 by 18. If for 18, you need 75, or 1 gram, you will need 75 by 18. For 1000 gram, you will need 75 by 18 multiplied by 1000. Either you can write it directly, or you can put the value of mass here and then put the value of specific heat as 75 by 18, totally your choice. Now, what is the value of Q here? That is given to be how much heat is supplied here? 1 kilojoule, that is 1000 joule heat is applied here. Directly solve this, you will get your answer. What you should know is the formulas of heat capacities here, molar heat capacity, specific heat capacity. From directly, you can solve the questions from heat capacities. Next is, 1 mole of ideal gas undergoes a change of state from this to this with a change in internal energy, change in enthalpy. Very, very important question. So here they have given you P and V are changing. They are saying internal energy, they have given enthalpy, you have to calculate. Remember, delta H is also QP, delta U is also QV. So directly you will put the value of P delta V here. That will be delta of PV. Delta of PV means P2 V2 minus P1 V1. Right now they have asked you one question, same on this, but they have given one reaction. Right, from there you have to answer. If no reaction is given, P and V is given, you have to apply this formula. Directly put the value of delta U, put the value of PV here, and directly you will get your answer in liter atmospheric. Remember, if they have asked the question in joules, you have to convert it into joules. Okay? Units are very important in physical chemistry. Then there is a solution containing 4 gram of polyvinyl chloride in 1 liter of dioxane was found to have osmotic pressure. Very, very important. They have asked at least 2 shifts where osmotic pressure question, or depression in freezing point, boiling point. These are very important. Colligative property, at least 1 question will be there on colligative property. Osmotic pressure of this, at this, the molecular mass they are asking. So directly apply this formula, pi is equals to CRT, that is, what is C? Concentration is number of moles by volume. So volume will be in liters here. Number of moles is weight by molar mass. So now pi is given to you, and this 1 liter volume is also given to you. So that is 1 liter. Pi and 1 you have put here. Weight is given to you, that is 4 here, 4 gram, right? This is what they are asking you. Value of R and T you have to put yourself. Whenever we are solving things in liter atmospheric, you have to put the value of R as this. Whenever we are solving the value in energies, then this will be the value. Okay. Next is a mixture of benzaldehyde and formaldehyde on heating with aqueous NaOH solution. Acha, benzaldehyde and formaldehyde. Benzaldehyde and formaldehyde. If you see this, you can easily see there is no alpha hydrogen. So the one will be converted to alcohol, one will be converted to acid. The one which has less steric hindrance will be converted to acid here. This question they have asked already in a different way. So easily they can ask you one more also. Either Aldol or based on Cannizzaro, you will definitely see one question. So answer will be benzyl alcohol and sodium formate is formed here. Next we have is, for a first, let us see if this is the last question. I think that is 1, 2, 3. Okay, we are at the last third question. For a first order reaction, this is A to B. Concentration of A changes from this to this in 40 minutes. The rate of reaction for the concentration of A is this. Okay. Okay. The rate of the reaction when concentration of A is this. This is what they are asking. So very simple. The concentration of A changes from this to this in 40 minutes. Firstly, you have to find the value of what? K directly. K is equals to 2.303 divided by T, natural log of initial by final concentration. Solve the value of K from here, right? Then the rate of reaction when the concentration of A is this. They are asking you the rate of reaction when the concentration of A is this. Because it is a first order reaction, so you just have to put R is equals to K into A. K value you have solved, put the value of A as 0.01 and you will get the value of rate of the reaction. Okay? Yes, there will be a session like this for mathematics just after I end the stream here. Okay? Next is, if a reaction follows the Arrhenius equation, the plot natural log K. See, Arrhenius equation again very important. Definitely they will ask you one question based on Arrhenius. That is E raised K is equals to A E raised to power minus EA by RT here. So directly what you will do here is, if you see the natural log of K is equals to natural log of A minus of EA by RT. Now you are saying you are taking plot of natural log of K versus 1 by RT. That means this is your RT. Okay, this is X, this is Y, Y is equals to, this is MX, this is C. The energy required, if they are saying the slope is this straight line with the gradient of minus Y. Okay. So that means slope that is equals to minus Y, right? That is equals to minus Y is equals to minus of EA. So that means EA will be equals to Y here. So answer is going to be 4th is the correct answer. So directly from that we have solved by equating the two formulas. Always remember one more thing here, that they can also give you theta value for slope. Slope is equals to tan theta. This so Namrata ma'am is going to teach you in the next session how to do trigonometry. Hai na? So that too, you guys are pro in trigonometry more than me. Next is the last question of today. The rate of first order reaction is this at 10 minutes and this at 20 minutes after initiation. Find the half-life of the reaction. Right? They are asking you the half-life of the reaction. For that, firstly, you will find the value of K, right? From that, you will put the value of K as T half is equals to 0.693 divided by K. You will put this value, you will get your answer for T half here. Right? Remember some of the important formulas of chemical kinetics, that is directly proportional to 1 minus N, and K is equals to mole per liter per second, where mole per liter will have 1 minus N. Because on T half also they are asking you so many questions. Okay. So that was your last question here, as you can see. So directly you can calculate the value of K right from here. Once you calculate the value of K, put this in T half, you will get the answer for T half. Just remember that whether they have given you T half in minutes or seconds. Okay, understood? Yes, everybody? Just give me a second. I'll just... Beta, after this, Namrata ma'am is going to take the session, right? So I'll just show you here. So firstly, to like this session. Let us see how many likes you have given to Vedantu NEET English and to your Diksha ma'am, right? Beta, here what you will see on this channel only over here in the live section, you will see a session for this top 50 maths question that is live at 5:30. Okay, so ma'am is going to get live, right? Okay, so in just 5 minutes, I guess, ma'am is going to get live here. So yes, do hit the like button here as well. For mathematics and chemistry we have done already. Now on Monday, VIT Triple E question, okay, we are going to take up for the students who are preparing for VIT Triple E as well, right? So for VIT Triple E, the session is going to be at 12 p.m. for chemistry. So hit the like button here as well. No likes, what is this, right? So hit the like button here as well, and here also for maths, just the like button here as well, right? That is going to be 12 p.m. and 7 p.m. is going to be the timing here for your VIT Triple E sessions. Is that clear? Now for all my students here, beta, if you see here, for all the students who have their class, who have their shifts, upcoming shifts, for you, all exceptions in one go. If you see this video, I have done all the exceptions, starting from even the exception from coordination chemistry directly here. So you can go through that here as well. Then if you see this here, we have done complete organic chemistry as well for you. Complete organic chemistry, all the naming reactions, everything you will see over here. Okay? Everything you will see over here. Wait a minute, let me just show you that. I think it has zoomed out a lot. Chalo, no worries. Chalo, no worries. Let us see in video section as well, na? In video section. In this video section as well. I don't know why I'm not able to go to the video sections here. So in the video section as well, you will see that all formulas in one go of physical chemistry are there, all the important formulas. Now on your Telegram channel, I'm going to send you two important charts for your D block and F block, the chart of electronic configuration and the atomization, all the things that they ask, from which chart they are asking you that question, that I'm going to send, right? Okay, by that time to all the students here, right? Beta, if you are preparing for JEE Advanced as well, then this is Rank Accelerator book for you. And also we have Eklavya batch where JEE Advanced preparation is going on right now. And if you guys are preparing for any other state engineering exam, so these are the test series that we will provide you, right? If you are preparing for, let's say, ma'am, specifically ISR, specifically BITSAT, then the specific test series are provided to you. 10 mock tests each will be given to you for each exam, right? But if you're like, ma'am, I am preparing for all the exams here, can I get a test series which will give me all the test series for all the different exams. So that is extra mile engineering test series, which includes the test of all this that I have mentioned here: PhD, KCT, VAT, EEE, EAM, ISR, SRM, KIT, KIIT, WB, BITSAT, and Comet K. All of them are there in this test series. So according to your demand, according to your need, you can see what thing you want to purchase, whether one single test series or a test series that has all the different state engineering exams. Okay. So that's it for today. Now Namrata ma'am is going to join in 5 minutes. Till then, bye-bye, see you. And all the best to all of you, and do well in your exams. Go through these 3 videos for your 7th and 8th April. Very helpful they will be for you for your 7th and 8th April exam. Till then, bye-bye, take care. See you all in the paper discussion, or in also the 12 p.m. we are going to do VIT EEE. So I'll see you all in VIT EEE session at 12 p.m. Bye-bye. Take care. See you all.